Bismillahirrahmanirrahim. These are numerical problems to Unit 11 Sound, Physics 10, the new book, National Book Foundation. Question 1. In a busy street, traffic noise has intensity of 10 power minus 5 watts per meter square. Find the intensity level in decibel. So the given is intensity. I is given 10 power minus 5 watts per meter square. The intensity of the faintest audible sound, that is the reference sound, is I naught is equal to 10 power minus 12 watts per meter square. And we need to find the intensity level beta. The formula for the intensity level is beta is equal to 10 log of I over I naught. Now substitute the values of I and I naught. This becomes beta is equal to 10 log of 10 power minus 5 divided by 10 power minus 12. Now you know that using the laws of exponents, this denominator minus 12, once it goes to the numerator, it becomes positive. So minus 5 plus 12 becomes positive 7. So it becomes beta is equal to 10 log of 10 power positive 7. Now, considering the laws of logarithm, if it is log of a power n, the n comes as a multiplier with the log. So this is written as beta is equal to 10 power 10 into 7 log of 10. Now, you know that log to the base 10 equal to 1. So log of 10 is equal to 1. So now since log of 10 is equal to 1, this remains 7. So beta is equal to 10 into 7 becomes 70 decibels. So the answer to this question is 70 decibels. Question 2. Mosquito buzzing has intensity level of 40 decibels. Calculate the intensity of this buzzing sound. Now here we need to find intensity I. So given is beta 40 decibels, intensity of the faintest audible sound that we know is I naught is equal to 10 power minus 12 watts per meter square, and we need to find intensity I. So again the same formula, beta is equal to 10 log of I over I naught. Substitute the values, this becomes 40. This is the beta. 40 is equal to 10 log of I over 10 power minus 12. Now swap sides, 10 log of I over 10 power minus 12 equal to 40. Now dividing by 10 both sides, this 10 eliminates and this 40 becomes 4, dividing by 10. So log of I over 10 power minus 12 is equal to I over 4. Now taking anti-log on both sides, this becomes I over 10 power minus 12 equal to 10 power 4. So move minus 10 power minus 12 to the right hand side, or I is equal to 10 power 4 into 10 power minus 12. Now 10 positive 4 and 10 power minus 12. This is the laws of exponents. Adding these two, 4 minus 12 equal to minus 8. So this becomes intensity is equal to 10 power minus 8 watt per meter square. Question 3. What is the intensity level of threshold of hearing and threshold of pain? This is not a numerical problem, and this probably has been given by some error in the book in the numerical section. Anyway, the answer to this question is that first you need to understand threshold. This word threshold is used here as well as it is used in the MCQs as well. So I must explain the word threshold. Threshold is what you step across just before you enter a room, a house, or any other region or space. This is the first place where that you just enter when you need to enter a room or a space or a region anywhere. So threshold of hearing is 0 decibel, or in terms of intensity of sound, it is 10 power minus 12 watts per meter square. That means once you below this, you cannot hear. The threshold of hearing is 0 decibel, or it is 10 power minus 12 watts per meter square. The threshold of pain that is 120 decibel, or in terms of intensity of sound, it is 1 watt per meter square. So this is now question number 4. Speed of sound waves in water at 25 degrees centigrade is 1480 meter per second. And if their wavelength is 70 cm, find the frequency of these sound waves. Now, given is the speed of sound in water is velocity is equal to 1480 meter per second. Wavelength in water is 70 cm. The lambda can be written as 70 over 100 equal to 0.7 meter. So formula for the speed of sound is V is equal to F lambda, or making F the subject becomes F is equal to V over lambda. Now putting the values in the formula, F is equal to 1480 divided by 0.7, making the calculation results in F is equal to 2114.3 Hertz, or approximately 2114 Hertz. Question 5. What is speed of sound at 15 degrees centigrade in air if speed of sound is 332 meter per second at 0 degrees centigrade? Now given a speed of sound at 0 degree, that is V0 is equal to 332 meter per second. To calculate the speed at temperature equal to 15 degree, and that is V 15 degree is equal to this is what we need to find, and the formula we use here is Vt is equal to V0 plus 0.61 T degrees. Now here V0 T is the speed of sound at temperature T, that is 15 in this case, and speed of sound at 0 degree, this is V0, and T0 is the temperature in Celsius scale. So putting in these values in the formula, so V at T0, that is 15 degree, is equal to 332 plus 0.61 into 15, and this results in about approximately 341 meters per. Question 6. Find the range of wavelengths for the audible sounds if the minimum frequency is 20 Hz and the maximum frequency is 20 kHz. Since the speed of the sound is not specified here, we will take the speed of sound at 0 degree centigrade. So it is 332 meter per second at 0 degree centigrade. So V is equal to F lambda is the formula, making lambda the wavelength as the subject of the equation. This becomes lambda is equal to V over F frequency. That means wavelength at 20 Hertz. Now it is lambda is equal to 332 divided by 20. This results in 16.6 meter, and wavelength at 20,000 Hertz becomes 332 over 20,000 becomes 0.017 approximately. This is the wavelength of at 20 Hertz. Question 7. During thunderstorm, thunder sound is heard after 3 seconds of lightning flash. Find the distance of clouds from the ground, and speed of sound is 340 meters per second. Now here, speed of sound is heard 3 seconds after the lightning flash. This means that the light and the thunder occur at the same time, but light reaches instantly and sound takes 3 seconds to reach the listener. When we say light reached instantly, in fact, the speed of light is very fast. It is 3 lakhs kilometers per second, or it is 300 million meters per second. So if the normal distances of clouds from the earth, if we take that, the time that the light takes to reach is so small and it can be ignored, so we consider it instantly. So time taken by this sound wave to reach the listener is 3 seconds, and speed of sound is taken as 340 meters per second. Distance of the clouds that we need to find, S is equal to Vt. So putting in the values, distance S is equal to 340 into 3, that makes 1020 meters. Question number 8. This is the last question. Here I would request all of those who have not yet subscribed to the channel, kindly subscribe it now. If you like these videos, share it with others as well. And if you have any comments or any observation about any of my solution, please write it in the comment box. These comments will reach me and I will be able to address your problems. And if you wish me to solve any particular problem, please do that I will be able to solve your problem and give you the solutions on this channel. Now, this question number 8 says, Sonar, the sound navigation and ranging system, sends ultrasound signal towards sea. It is received back after 5.3 seconds. Its speed of sound in sea water is 1550 meter per second. Find the depth of the seabed. Here, the depth of the seabed be D. Let the depth of the seabed be D. Now, let the total distance level be S. Total distance is for the wave is going up to the seabed and then returning back to the source of signal. Now, the ultrasound signal goes to the seabed and returns. That means it travels distance D twice. That is S is equal to 2D. Time that the wave takes to go to the seabed and back, T is equal to 5.3 seconds. And speed V in seawater is 1550 meter per second. The formula involving distance S, uniform speed V, and time T is S is equal to Vt. Now substitute S is equal to 2D, T is equal to 5.3 second, and V is equal to 1550 meter per second. And 2D is equal to this 1550 into 5.3. Divide both sides with 2 to find the depth D. So D becomes equal to 1550 into 5.3 divided by 2. And this results in D is equal to 4107.5 meter. So this is all for now, and we'll meet for the next chapter now.